In this video, we'll solve an application of systems of equations involving interest. Janice borrows a total of $8,000 in student loans from two lenders. One lender charges 3.6% simple interest, and the other charges 6.5% simple interest. She is not required to make any payments for 2 years. At the end of 2 years, she will owe a total of $721 for the interest from both loans. How much did she borrow from each lender? I've organized this information in a chart. We have account in the first column, principal, rate, time, and interest. In the first row, we have the information for lender 1. We don't know the principal amount. The rate was 3.6%, which written as a decimal is 0.036. And then the time in years for this loan is 2 years. And then we need to figure out an expression for the interest. So remember this formula that simple interest is principal times rate times time. So if we know the first 3 columns, we multiply those to get the final column. Since we don't know the amount that she borrowed from the lender 1, we're going to represent that with x. So multiplying 0.36 times 2 times x gives us 0.072x. In the next row is lender 2's information. We don't know the amount that was borrowed from lender 2, so we're going to use the variable y to represent that amount. Again, the rate was 0.065 and the time was 2 years. If we multiply those 3 quantities together, that is 0.065 times 2 times y, we get 0.13y. Now our goal is to solve this problem using a system of equations, and so we need 2 equations with the 2 unknowns that we have. Notice that I have a third row here that represents the totals. We know that the total borrowed was $8,000. So one of our equations is going to be x plus y equals 8,000. Then the second piece of information we know is that the total interest that she owed is $721. So in the final column, if we add the interest from the 2 loans, we should get $721. So the second equation will be 0.072x plus 0.13y equals 721. So then we can solve that system in a number of ways. The first thing you may want to do is to get rid of the decimals in the second equation. Because we have 3 decimal points in the first coefficient, we can multiply that second equation by 1,000. And that will give us an equivalent system. We have x plus y equals 8,000. And then in the second equation, 1,000 times 0.072x is 72x, plus 1,000 times 0.13 is 130y, and then 1,000 times 721 is 721,000. Now you don't have to get rid of the decimals, but I think it makes the equation a little bit easier to work with. Now we can use the elimination or addition method to solve this system. We can choose to eliminate x or y. If we want to eliminate the x variables from the system, notice that we have a 72 as a coefficient on the second equation. So we need a negative 72 to add to that. So if we multiply that first equation by negative 72, we would get negative 72x minus 72y, and then negative 72 times 8,000 is negative 576 thousand. The second equation stays as is, 72x plus 130y is equal to 721,000. Now we can add the equations in the system together. The x terms add to 0. Negative 72y plus 130y is 58y is equal to 145,000. And then we divide each side by 58. Therefore, y is 2,500. Now, once we know y, we can solve for x. And to solve for x, we know that x plus y is 8,000. That gives us that x plus 2,500 is equal to 8,000. So when we subtract 2,500 from each side, we get that x is equal to 5,500. Which means that Janice borrowed $5,500 from the first lender, or the $5,500 at the 3.6% simple interest, and $2,500 at 6.5% simple interest.